Welcome back. This is chapter 6, and this video is part 4. In this video, we're going to jump in talking about static local variables. So what are static local variables? Well, local variables only exist while the function is executing. When the function terminates, the contents of local variables are lost. What static does, it takes local variables and retains their contents between function calls. Static local variables are defined and initialized only the first time the function is executed. 0 is the default initialization value. So what they're saying is, what we're talking about here is we can have those local variables we talked about previous that, like in here, x1 and x2. Once I leave main, those variables no longer exist. More importantly, this return x in this function, once I leave this function, it no longer exists. However, using static, I can make them. I can make these variables not go away. So here's an example. We've got a function prototype show local. We've got our int main that's showing local, and then returning 0. And here's what that show local does. So we set up a variable called int local number 5. It's a local variable. We see out the local number is local number with the end line. And what you're going to see, and then we're going to say local number equals 99. Now what you're going to see is, because this is a standard implementation of a variable, this local number is going to be destroyed when we hit this end bracket. So even though we called it twice, the local number is going to be 5 and not 99, because again, even though we set it to 99 here, once we hit here, it's going to be destroyed. So the next time we call it, it's going to come in here and set the local variable again and output 5 again. It's going to set it to 99 and then destroy it. So let's do that, but with a different approach. So we're going to say show static. We're going to say int main, and we're going to sit in a loop for 5 times. Here's our variable int count equals 0. So that's going to initialize as 0. We're going to do this until it's equal to 5, and then stop. And then each time we're going to increment, and then we're going to run show static. Now our static, the show static, this time we're declaring this variable int main with the static prefix here. And then we're going to say cout stat number is stat number and down. Now, then we're going to increment it and go away. Normally, once we hit this curly bracket, state number would be destroyed. But because we declared it as static, it will not destroy it. And the next time it comes in, it's going to ignore the fact that we've already established it. So it knows to ignore the statement now, because it's a static and it's already been created. It's already part of the scope of this guy. So it doesn't need to recreate it. It's going to ignore it. But what's going to happen is now it's going to output the state number. And because we incremented it the last time, it's going to be 1. And again, it's not going to destroy when it leaves. And each time it does this, it's going to increment the stat number and add it again. One last thing to remember in this is, because we're using the static, the system will automatically go ahead and assign this variable number to 0. Otherwise, if we didn't have the static, it wouldn't assign the stat number. So because we have the static, it goes ahead and it initializes it for us as well to 0, because we did not declare anything. If you do not initialize a local static variable, the initialization only happens once. So when we saw up here was, because we did not initialize it, it will only happen once. Remember I told you we'll ignore this statement now? Now, because we are initializing it with 5, it's going to start at 5 but it's going to stay at 5. It's going to retain the fact that it's 5. So if you don't initialize it, it will do it for you already, and it will initialize it to 0. So let's talk about default arguments. Default arguments is a way for you to assign a default to one of your parameters, so that way if it's missing, then you already have the value. So let's take a look at that. Must be a constant declared in the prototype. So in this, remember, with prototypes, we don't have to make the name of the name of the parameter. We just need to specify the type. But because we want to declare an argument, a default argument, we do have to say, though, that it's equal to whatever the default value is going to be. It can be declared in the header if no prototype. And then multi-parameter functions may have default arguments for the call of all of them or some of them. So in this case, these two have default values. So let's take a look at the use of this. In this function prototype, remember there's no names, but we are setting the first one to 10. So the default value is 10. And the second one is 1. And let's go ahead and jump down to the actual function. Helps if I pick the right thing there. And we have int cols. So here's our display stars. We've got int columns and int rows. Now you notice how in the function here, we don't put the default value. That's because we did it in the prototype. So we don't need to also do it here in the function. What's neat about that is because we've defined defaults, if we call the display stars and we don't pass anything into as parameters, it's automatically going to use the default ones we set up. So the output here is 10 stars by 1 row. The next one, we can say 5, which means we're going to override this default, and we're going to change this to 5, but we're going to use the 1. So with that being said, we should have 5 stars and 1 row. 5 stars, 1 row. Now we can display stars 7-3, which means we're overriding both defaults, and we're giving 7 stars with 3 rows. Now, if all the parameters to a function have default, if not all the parameters of a function have default values, the defaultless ones are declared first in the parameter list. So as you can see, this guy is not going to be okay because he has to be up here, up front. All variables that do not have defaults have to be declared first, and then all variables with defaults can be declared after that. When an argument is omitted from a function call, all arguments after it must also be omitted. So here, in this, we're saying, well, we're going to pass num1 and num2, but we're not passing the num3 because it has a default value, and that's okay. But we can't do this. We can't leave something blank in the middle and expect it to use the default. This is not okay. I wish it was, but it's not. All right. So using reference variables as parameters. Using reference variables as parameters, a mechanism that allows a function to work with the original argument from the function call, not a copy of the argument. And it allows the function to modify values stored in the calling environment, and it provides a way for the function to return more than one value. Give this a moment. I'm going to show you what they mean by this because technically a function can only return one value. So think back to when we created some, we were passing variables by value. And remember, on by value, that meant it copied whatever was being passed to the function. The function actually got a copy of it and used the copy and then destroyed the copy when it was done. That meant if your function changed whatever was copied to it, it wouldn't change the original calling version of that variable. It wouldn't do that. Here is how you can do that. So this is the opposite, and this is what I was telling you when we were talking about that. This is a little bit more tricky, especially the mechanics behind the scenes. But let's just talk about it as a whole and say that what this allows us to do is take and pass in, like in this add numbers, I have the ability to pass in these variables and then change them up in here, and it will also change them down here. Because right now, this method doesn't do that. This method gives copies to this function, so any changes made in this function will not be represented out here. So, Professor Waits, how do you do that? Well, a reference variable is an alias for another variable, and we define it with an ampersand sign. Changes to a reference variable are made to the variable it refers to using when we use reference variables to implement passing variables by reference. So what we do is this little mark right here, this and sign, tells the compiler not to make a copy anymore, but to actually use the variable that's coming in without a copy. Use that actual original variable. So think about this. Think of memory as kind of this big box. And in our memory, we have our value here. When we pass by value, all of a sudden, the new function will actually copy that whatever was in here over into another spot in the memory. The new function will use it, and then when it's done, it actually destroys this copy, and that's why nothing changed over here. Well, when we're passing by reference, we're saying don't do that. In fact, behind the scenes, what's going on is we have this spot in memory, and it has an address in in the memory of where this is located. When we specify the and sign, we're telling it, instead of passing it by value and making a copy, pass by the actual address instead. So in memory, we might have a space of 016A. That's a memory space. So what happens is the new function gets passed this rather than this. And because of that, when it makes changes to whatever is stored at this variable's address, it will also change it for the original color because, again, it's the same thing. It's not a copy. It's the same thing. So that's why it's called by reference, because the address is the reference to where the variable is located, and we're passing this address rather than the actual value. So let's see how that looks. Again, in our prototype, we're just specifying that this int is going to be passed with the ampersand sign, meaning, hey, we want to use this as a by reference rather than by value. So down here, we set up this variable, and let's go ahead and when that int value for, okay, we're going to make a space in memory, and let's again say that the address of this memory is 1, 2, 3, Charlie. And in that space, now we're going to assign 4. When we call this double num, what's happening is instead of passing 4, we're actually passing the address because we've specified that to do it that way with this ampersand sign. When we do all this, if the function down here, which I don't know if the so unfortunately my pen won't stay with the page. That's okay. And as you can see, we once again down in our function have to specify the ampersand sign again, but we're going to do it with the name of the variable next. So what happens is if we take that and we say times equals 2, it's actually going to take the value that's in this address and do the times equals 2, which means it's going to change this to an 8. All right. Now, what's so good about that? I'm glad you asked. So now this value, when we reuse it again, instead of it giving 4, because it's in the scope here is 4, we changed it in memory to actually 8. So now the value here is changed also. The contents of this value have changed to 8 as well. And that's why we're going to see 4, now calling the double number, and the value is now 8. So that's how you pass by reference. Some notes that you need to know about reference passing via reference is each reference parameter must contain the the ampersand sign. Space between the type and the ampersand sign is unimportant, so you can put space. And there is definitely, I don't like putting space, but I know plenty of people that do. Must use the ampersand in both the prototype and the header, which we saw. Arguments passed to reference parameters must be a variable. It cannot be an expression or a constant. It can't be a literal as well. And then use when appropriate. Don't use when arguments should not be common changed by the function, or if function needs to return only one value. And what they're saying here is, again, you run a little bit of a risk by doing this. And by doing this, your other functions can now change that piece of data. And in the programming world, we don't typically like that too much unless there's a real good reason to do it, because you can have a function somewhere way off in the wild all of a sudden changing your data, and it's just really hard to debug. You don't know why it's doing what it's doing. You literally you can spend hours looking for this one little change. So we don't really like to let other things have the access to change our variables. In this case, what I'm talking about is int main should not really like the idea of some other function being able to change its local variables. And so we try to avoid that. What they keep talking about, let me make sure, they're not. What they keep talking about is returning two variables, is because in this case, and which is funny because they didn't even do a real good job of this, is essentially, let's say I wanted to change this to a bull. And then in here, what I could say is, by using this, I can return. I'm basically returning an augmented value, right? I'm taking this ref var and I'm multiplying it by 2. Then I could also say return true, right? So I have actually, in theory, return two values. I returned a changed version of that, and I'm returning a bool. What's nice about this is, what we like about this is, think about if we were if we were reading from a file, I could have bool read line and say st, my string %sign string for just bear with me for those that are already going, yeah, but strings are reference values anyways. But just bear with me, string %string. I could then read the line from the file and store it in the string var and return true if it was successful. If for some reason the file, let's say we're at the end of the file, then I would maybe get an error or I would get a null back. And so instead I would return a false with nothing in the ref var. So now I'm technically returning for all, again, for what they're saying here in the book, I have the ability to return more than one variable. It's not really returning a variable because you're augmenting the variable in memory, but that is one way of, if you ever go, man, I wish my function could return two variables, this is how you would go about making that happen. All right. Overloading functions. Overloading functions have the same name but different parameter list. So think about my add numbers here. Well, what if I wanted to do another int add numbers double x1 double x2 bool do output. Do, by the way, is another very common prefix that indicates more than likely it's going to be a Boolean value. So here we can still do the same thing and say x1 plus x2. And then we can say if do output cout, the answer is N9. Because it still has a return value, so it still needs to return that value. But in this case, I'm allowing for the nice use of, hey, you know what? Down here on this crazy one, let's just go ahead and have it do all of it. So now I'm using, and you can see I have two functions with the same name, but a different list of parameters. The compiler knows because of this, when I use this add numbers, it's going to use this first one. But this second one, because I have three parameters, it's going to use this one. So this can be used to create functions that perform the same task but take different parameter types or different number of parameters. The compiler will determine which version of function to call by the arguments in the parameter list. So as I was showing here, the fact that this has two doubles and a bool, it knows that the fact that I'm doing two ints and a bool is smart enough to know, okay, use the one with the two doubles and the bool, because ints can be translated into doubles. I think that works. So, you know what? We should check that. Make sure the compiler is smart enough. It is. I'm sure that they're going to kind of give us some examples. Here's an example of 4 different ways. So this is the first method, but we have all these other methods known as overloading, and they may do something slightly different. Or in this case, they could do something pretty similar, but because now we have the double-double, we may want to be a little bit more precise in this particular method. So in this case, we were talking about how then we can use it. So this is an example of where one common reason why we often do overloading is because in this case we have an int that we're going to square and a double that we want to be able to square, because we want to be able to do it slightly different. In this case, again, our code is the same in the two, but it's going to slightly treat things slightly different because it's going to be more precise with the doubles than it will be with the int. And then the exit function. The exit function terminates the execution of a program. It can be called anywhere in the function and can pass an int value to the operating system to indicate the status of the program termination. Usually used for abnormal termination of a program. Requires this particular header file. And so with the exit function, you can see here us just using it blatantly. We're passing back the 0, which tells the operating system nothing's wrong, but go ahead and exit out. Part of that cstdlib header, there are two constants that are commonly passed to indicate success or failure. We can now start using those because we already have to include this header to use exit, and part of that header has this exit success or exit failure. And again, because they're all capitals, we know that they are constants. And then we've got stubs and drivers. So stubs and drivers, useful for testing and debugging program and function logic and design. A stub is a dummy function used in place of an actual function. Usually displays a message indicating it was called. May also display some parameters. A driver. The driver is a function that tests another function by calling it. Various arguments are passed and return values, and the return values are tested. Let me talk a little bit about stubs. Stubs are actually very common when you're developing, especially when you're on a team, because a lot of things are moving at the same time. Or maybe you don't have all the details, but you'll have something big. So let's talk about the two scenarios. If you have some requirements that say, hey, we want to take some data and we want to output it, but we don't know if it's going to be output to a printer or if it's going to be output to a file. We're checking with the customer right now. I could write a stub, which is a dummy function that says output data, and then just in there, I'm going to probably do something like cout, this function is being called. And then go back to my other stuff. I'm going to go work on pulling in the data and getting the data coming in correctly, wire all that up, do all the menus that need to be done. And then finally, I can go ahead and start testing even and making sure everything else works. Finally, the customer is going to come to me and say, oh, okay, we want to output to a file. So I'm now going to go into my stub and I'm just going to go ahead and put in the details of outputting it to a file. And because it was a stub and because it was in my code, it no longer is considered a stub, but it already was working as a piece of my code. And now it's just going to use the new body that I've just typed in for it to output the data to a file. So that's a good example of a stub. When we come to drivers, drivers are functions that test other functions by calling it. So we might want to, while programming, set up some functions that we can run that's going to call other functions just to test that the function's working. For example, in our add function here, we could set up a driver that will call add number with certain numbers. Maybe 1 plus 1 should be 2, 1 plus 2 should be 3, and so forth and so on, and do that 5 different times just to make sure that we get the correct number back. And because we're doing that through a test, we have a function calling another function to test it. That's known as a driver. All right, that is the end of this chapter. I know there's a lot of data to take in. You may need to watch a couple of these videos a couple of times. If you've got questions, make sure you shoot those questions over to me. And I hope you have some success on the homework, and we'll see you later.